Oh, I can see myself. Good. So, yeah, my name is Korostelev, if someone doesn't know. My GitHub handle is Nadako, and I'm going to talk about the game I'm working on currently. It's Forge of Empires by Games. I joined them around a year and a half ago, and I'm working on migrating this to Haxe. So just to get some idea, Forge is quite a large browser and also mobile game. It has city building and it has some nice research like in civilization or whatever. It has some exploration and it has even some battle like heroes or something. And yeah, maybe you remember this guy. It was at Amsterdam Haxe Summit. His name is Andre, and he came with basically the whole Haxe sporting team, describing what they did with their code base to make it work on HTML5. And today I'm gonna talk a bit more about this actually. So before I joined, the team tried different technologies, and they settled with Haxe and also OpenFL for the HTML5 fork. They also made the ActionScript HX thing work, because it don't just work on the code base, on a random code base, but they made it work, and they developed a nice continuous conversion pipeline where the existing ActionScript code were just automatically converted and compiled to HTML5 and just published, uploaded to the CDNs and whatnot. And yeah, that was pretty nice. That worked, and so they could just continue developing the game while improving the HTML5 version. And of course we had some issues, or they had some issues, and then I joined and helped fixing them. Basically there are two big issues. One of this is HTML5 performance with OpenFL. It was not sufficient enough because the game was not really optimized for modern rendering, and also even the stuff OpenFL does every frame on the CPU is not super optimal, so we had to optimize this at least for our code base. And also the behavioral inconsistencies between Flash and OpenFL made it quite difficult to work actually, because the main development was still in Flash, and the developers were working on Flash, and then they compiled to HTML5 and they saw that the game looks or works differently, and that is of course a problem, but we overcame all this. This is all now fixed. More or less, we of course still working on this in our OpenFL fork, but so far the game is live and it's a default version. The HTML5 version is the default one, so it worked out pretty well. But still there are issues with the building pipeline, which was quite a bit complex with all the preparation steps, and then AS3HX converting, and even the library installation, all these things, and that's what I am trying to simplify. And of course one of the biggest issues that we are still developing with the ActionScript toolkit and in ActionScript language, which is not super nice because Haxe is so much better, especially with all the latest features that we have. So we decided to improve that situation, and there are first we of course looked into maybe improving the AS3HX, and we found out that it's okay-ish for the actual compilation for runtime, but for development it's not super nice because the code that it produced was not really nice to work with for actual humans, and that comes from a number of issues with the AS3HX, and mainly it comes from the part that it just parses the ActionScript source code into syntax only, syntax tree, and it doesn't have any really information about the types, and also not important things like comments and white spaces are part of the AST, part of the syntax tree there, which is kind of nice because we can preserve the comments and white spaces, at least in some cases. But also it's not nice because it's very, very annoying to work with such an AST, because you have to always consider that the node can be a comment or white space or something like that. And also the actual typing, which means trying to figure out the type of a node, is super complicated in this tool, because there is some typing going on, but it's done on writing the actual hex output. So it works, I think, okay-ish for local vars, because we can quickly analyze it, but it doesn't really have a typed representation of the whole program that we are trying to convert. So it makes it really hard to make assumptions about everything, basically, and we can't really do any nice transformations on this code. So it's because of all that, it's kind of hard to produce a code which is nice, it's close to original, and also it's more Haxe, I guess. Because yeah, I'll show you some examples later. So the solution is the new converter, and it starts with the what I called full fidelity parsing, and here is the example of the parse tree, basically. Oh, okay. Okay, that's not me. That's anyway. So yeah, we have we parse, of course, everything to tokens, but also we only have nice tokens which make sense, like ampersands or pipes or identifiers, some braces, and all the white space and comments are not stored in the tokens. It's stored in something called trivia, which is attached to token. So this way we can afford not to care about the comments and white space, but we still carry it through the whole process with this data structure. And this is how the AST look like, the parse tree. For example, we have an identifier which refers a token which has all the information about the syntax, and we have similar stuff for blocks which have the references to open brace and close brace, and also an array of block elements which consist of expression and an optional semicolon. So that way we can parse the whole ActionScript codebase into a nicely full fidelity parse tree that retains all the information. And then we convert that to a typed tree, which is really similar to Haxe actually, except that it's a little bit different, but the main difference between parse tree and the type tree is that every expression, everything actually in this tree has a type attached to it, and also the expected type attached to it. I will talk about this a little bit later. First, I want to point out some key differences. For example, if we take another look at the parse tree, we have this identifier node, which is just some word. But in the type tree, we don't have just some words. We have things like local vars or field access, which talks about more semantics of the language. Yeah, and because we kind of still need to retain all the syntax information, we also have token references in these expression nodes. And when we are building this type tree, we assign a type which is known from the context to every expression, and also the expected types, which could be the type of variable that we are trying to assign to, or type of the argument that we are trying to pass, and so on. And these are the types. Mostly they refer to the ActionScript type system, so it has some special types like the basic types, and also some things like XML and XML list, which has some special meaning, in ActionScript, at least for the conversion, and also vector, array, dictionary, whatever the types that we care about to make a nice conversion. And of course we have types for function and class instances and class type values. Yeah. Now the new converter also supports loading all this type information from the SVC libraries, because we use quite a lot of them. For example, we use Starling, Robotlex, and some extensions to that, and we don't want to do anything manually for that, so we just using the format library, which is super nice. It works everywhere, and it allows for loading all the needed information directly from the SVF libraries, which is nice. And we load it into the same type tree, but just with the dummy tokens. So yeah, and to make things even more nicer, the converter supports additional type annotations for stuff which is naturally untyped in ActionScript. For example, the array is untyped and the dictionary is untyped, basically because there's no way to annotate this in ActionScript, but we want this for Haxe, because Haxe is more strictly typed, of course, and also we can use that information to make more clean conversion. So we support this kind of comments on fields and on arguments, and also this kind of configuration that overrides the types in the loaded SVCs. So this is also kind of nice. And yeah, after we built this, so at this point when we load all the SVCs and parse all the code, type it, we have a complete typed representation of the program, and we can run a number of filters on that. Basically their work is to clean up the code, adapt it for Haxe, insert missing type conversion, remove redundant type conversions and other redundant code. So we have quite a lot of them. As you can see, there are like things to deal with E4X syntax, for example, or some API stuff, or some castings, of course. Switches is a big issue because there are different for loops and so on. So we just run this series of filters in some order. It's also quite similar to how Haxe actually works. And then we just dump this type tree in a file, in multiple files, and here how it looks like. So for example, we have some ActionScript file with some Haxe type annotation, some downcasts, some syntax like this one, which is not supported in Haxe, of course. It also involves implicit to Boolean conversion of a value, which is also not a thing in Haxe. It has uninitialized variables which are allowed to be used in ActionScript but not in Haxe. Also we can see this line with the amount. It's kind of interesting because, so you can see here the item has the amount with type number, but in ActionScript we can just assign it to int and that will work. But of course this is not safe and Haxe won't allow it, so we have to do something about it. And then there's a for loop, like normal C for loop, and some more to Boolean implicit conversions here for the check. And we convert this to a nice Haxe code with a proper function signature instead of just untyped function. We strip out this downcast, because now when we know that the function returns an item, we don't need this downcast because there's no way the function can return anything else. So this works. We of course also rewrite all the unsupported things, and also one nice thing is that the converter removes the redundant type annotations, because we can because Haxe has proper type inference and ActionScript doesn't have. So in ActionScript you have to write it, and Haxe you don't. So this can generate some cleaner code, and the same happens to the initialized vars. We have to initialize them before usage, So we assign a default value here, which is 0 for int, and also we insert the missing conversion from number to int here. As you can see, there's an std int called. We convert the seal like for loops into hex declarative for loops where possible, of course. Where it's not possible, if the step is different or something, or it's like completely different, we will convert it to while, so it still works but not as nice. And of course we do some more checks, and for fields we also generate default initializations, because that's how it is in ActionScript or AVM2 maybe. All the fields of basic types have some default values, like none for float. And also, if we detect that we actually create an instance of a class and the class does not have a constructor, then we generate an empty one. But we only do this for the classes that are instantiated in the codebase, which is also nice, because sometimes the classes have only static fields and they are never instantiated, so we don't want to just add the constructor everywhere. So this leads to a pretty nice code, and we are pretty happy with that. And another nice thing that we have is that all the reflection, which is inevitably there in ActionScript, is nicely encapsulated into abstracts for working with reflection. So instead of generating directly the reflect set properties at field calls, we just generate the field access as it is, and we just have special types for this star type, which is basically dynamic in ActionScript. We generated this special abstract called ASN, which overrides the field access. And if we look at the JavaScript output, we have for normal field access, we have this nice-ish function call, which will do get property, and will also bind it if it's a function, because that's how ActionScript works, and we want to preserve the behavior. And the same goes for the setting. We do set property, and also the field access on ASAny yields another ASAny. So when we actually assign it to something which has different type, like int here, we have to do some type conversion, because again, this is the ActionScript semantics. So here we do this number call, and we also convert it to int here. So this works exactly like it works in ActionScript, and it looks easy to change. Also, it after we are done with the converting, we can just search for all instances of ASAny and replace it with something that makes sense, maybe with type parameters or structure types or something like this. So this is quite nice. And the most important thing, that it actually works. We now compile it to the converted code. We compile it to 2 targets. One of them, of course, is HTML5, Vue.js, and OpenFL, and some custom libraries. And another one is actually Flash. So we right now we don't really use the ActionScript code for anything else than conversion. We first convert the code to Haxe, and then we just have 2 different configurations to compile for HTML5 and to Flash. We have the SVF target and just reusing all the SVC libs that we used. And the converter, of course, is fully in Haxe, and it's really fun to work with. And it uses the JVM target, which proved to be really fast and nice and quite stable. So I'm really happy with that. Thanks, Simon. I want to talk about a little bit about the Flash target, because nobody cares about Flash. It seems so, but apparently it's actually really relevant, because there are a lot of players, at least in Forge, that still have like potato PCs, which are really slow and old.
Same here.
Yeah, and
Did you on purpose call them payers?
Yeah, because even though they can't afford a new PC with a new browser, they can afford paying for our game.
Well, now you know why they can't get a new PC.
I mean, yeah.
Give them 1 month of free playing to buy the.
I mean, it's possible to play without paying in our games. So it's not like we are asking for money or something. But anyway, this is still relevant and important, so we support the Flash version using the Flash target, and that works pretty well. We're still using the original SVCs, so it's super nice that Haxe can just load the external definitions from the SVCs magically. We kind of want to get rid of these SVCs just so we don't have to support also ActionScript code base for these libraries. We can just replace it with Haxe and compile everything to Flash with Haxe. That would be super nice. We can also improve some performance because we can strip out some typecasts and whatnot. But for that I had to do some work on the compiler, unfortunately, but now it's all done, so it's nice. There was some bytecode issues, mainly it's related with interop, like if we override a protected method, it was generated as an override public method in Haxe. I mean the protected method in the SVC, and that caused some runtime issue when we tried to load that bytecode in the Flash player, so I had to fix that. And also I had to rework Flash properties because Flash has a different notion of properties than Haxe, like completely different, and it was supported to some extent in Haxe, but it required a completely different syntax, some metadata, and so instead of just using Haxe properties, we had to introduce another setter method, mark it with a special setter or getter metadata, and this is not good because we want the code base to be clean of that, and we want to just use Haxe properties if possible everywhere. And we have a lot of properties because it's like normal ActionScript code, it has getters and setters everywhere, also setter only properties and all that shit. So yeah. And there are also some more minor issues with vector, because in Flash player the vector type should be always specified, like is it a vector of int or is it a vector of something else. Otherwise, for example, the downcast won't work if you just pass the vector, so I had to do something for this as well, but now it's all available in Haxe 4, so yeah, it works quite fine for us. And for the next steps, of course, we want to just dump the ActionScript code base and go full Haxe, and for that we just need to do some final touches on the converted code. Basically, we just need to review how if we are satisfied with everything in the converted code. So far it looks pretty nice, but maybe we will have some more ideas how to make it even more cleaner. And of course we need to prepare the development environment, because we need to set up the IDEs, the completion and all these things, and it's historically was a weak part of Haxe, unfortunately, but yeah, we still have to do something about this. And we need to educate the teams, of course, because Haxe is a bit different from ActionScript and the approaches should be a bit different. So I'm preparing to give some workshops in the company. And besides that, we want to help some other projects. We have at least 2 more projects which needs to be migrated from ActionScript, from Flash to Haxe, one of which I think even will go to native compilation, because it's actually a mobile project, so that will be another layer of fun. Because right now we are only caring about HTML5, but we will have to also care about the mobiles and native. But that's for the future, and I want to say a couple of words about Haxe 4. I was surprised to find out that compiler cache seems to be finally quite reliable. at least if you don't do crazy macro stuff. It works really nice. I can recompile the whole code base in seconds, and this is super nice. And the IDE services, they generally work reliably, which is also quite a good achievement for Haxe. But for a big code base, unfortunately, they are still quite slow because of this module invalidation things that should be optimized, and I'm looking forward to that. Yeah, so it was really nice, and that's all from me. If you have any questions, then please ask.
I have a question.
Yeah.
How long did it take you to build this new compiler or a translator?
I think I started this spring, so I guess around half a year. I was experimenting with the full fidelity parser for ActionScript a couple months before, and then I just took it to my supervisor at work, and we just started working on this.
So when will it be open sourced?
Yeah, that's a good question. I also asked my guys at the company, and the thing is, we are maybe thinking about using this commercially, actually, like not selling it, but maybe buying some dying Flash projects and reviving it with this tool. So this is kind of a business related question. I would like to open source it, but yeah, this is not my decision, unfortunately. But I guess if you're interested, you can contact our management.
Can't you make it depend on some GPL package, and then it all has to be open source?
I should look into that. I wonder what license does the format library have.
Yeah, maybe.
Good point. Okay, if there are no more questions.
Yeah, actually, I have one more question. Do you know anything? It's also business related, maybe, but if InnoGames is looking to use Haxe for new projects as well, or just conversion?
Yeah, I think they don't want to use Haxe for the new projects so far, because they are trying to reorient the company to mobile first development, and that basically means that they just want to use Unity. We'll see how it goes, because we can also of course use Haxe with Unity. That's possible, so we'll see. I don't know, maybe that also depends on me a bit, because I'm the Haxe guy in the company. But so far no. But still we use Haxe for the projects that bring the most money actually in the company. I'm not sure if that's good information though.
I think it's no secret.
Yeah, but Forge is super big, and there's also LNR, and there's other projects like Grapplis, which will be probably using Haxe as well. So yeah, Haxe is there to stay in our company.
But for the mobile conversion that you mentioned, that's for the future, it will also use Haxe then when it's
Yeah, because right now we have a mobile version of the game which is running on top of Adobe Air, and the situation with Adobe Air is not super nice. So we want to move away from Adobe tool at all, basically. Yeah. If there are maybe any questions on Twitch, someone knows.
I'm gonna check. I don't have the link for Twitch.
I mean, you can contact me anytime. I can reply to all the questions later. Okay then, see you.